Bismillahirrahmanirrahim. This question is from May-June 2024, variant 21. Question number one, topic measurements and units. In this question, the drag force Fd is acting on a falling object falling through air is given by. This is the drag force, that is ball, that is the falling body experienced, where A is the cross-sectional area, V is the velocity, rho is the density of the air, and C is the constant called the drag coefficient. Use SI base units to show that the drag coefficient have no unit. Okay, so drag coefficient have no unit. Drag coefficient is actually C. So let me rearrange this equation and let me make C as my subject. So C will be equal to 2 times FD divided by rho area and V square. Okay, so I know that the area has a unit meter square, velocity is meter per second, right? And density is kilogram per meter cube and we have to show that C is a constant and it has no unit. Okay. Okay, I already have mentioned all the units given in this formula. Uh, Now I will put these units according to my rearranged formula. One thing is very clear, I think so you know well that constant has no unit. So you can ignore the two. Okay, so let me put the values of the unit. FD is a drag force, and I think so you all know that force has the unit Newton, and Newton is equal to kilogram meter per second square. So if I put all these values here in this formula, kilogram meter per second square, the unit of the density is kilogram meter cube per meter cube. Area is meter square and velocity is meter per second, and I will apply the power also. So C will be equal to kilogram meter s power minus 2. Let me apply the power. So I'm in writing one extra step, kilogram m power minus 3 meter square, and this power will be applied in, and you know if there is no power the power is 1, so power that is outside on the bracket it will be multiplied inside, so it will be as m square s power minus 2. So now I will do some mathematics, and in this equation I can see this kg and this kg easily cancelled out, right? So no need to write the kg here. Then I will add all the powers of m. M has a power 1, so I will write m power 1. Then from the bottom it is minus 3, so minus 3 power is shifted on top as plus 3. Then there is another power plus 2 plus 2, so combinedly, I will write minus 4. Then s has a power minus 2 as a denominator, and downside s power minus 2. So when it will be shifted as a denominator, it will be written as plus 2. Okay, so final answer m power 3 plus 1 4 and minus 4, it will be equal to 0, and s power uh, minus 2 plus 2, it will be 0. And you know if ms both powers are 0 and anything power 0 is equal to 1, so C, I am getting the answer 1, so there is no unit, so hence proved, it is proved like C has no unit. Okay. Figure 1.1 shows a sphere falling at a terminal velocity. Whenever we have this term, this word terminal velocity, then it means the acceleration of the body is equal to 0 and the net force acting on the body will be equal to 0. And when net force acting on the body is equal to 0, then all the forces, up and down forces, are definitely equal. Assume that the upthrust on the sphere is negligible. Okay, this is given by the examiner. And on the figure 1.1, draw the label arrows to show the direction of the two forces acting on the sphere. So when an object is moving vertically downward with terminal velocity, then it is understood that two forces, that one is weight acting vertically downward, and one is a drag force that acting on the body upwards. So both forces are equal in magnitude, opposite in direction. So that's the reason body is moving with terminal velocity. So C part, the mass of the sphere is 49 gram. Calculate the drag force acting on the sphere. So to find out the drag force, this is very simple. W is equal to mass multiplied by gravity, because in question it's written find out the drag force. But I am using the equation F is equal to M is equal to W is equal to M into G. The reason, because I already have mentioned in the question, like drag and weight both are equal because the object is moving in terminal velocity. So whatever the answer of the weight you will get, it will be equal to the drag. So 49 given in grams, so I will convert it into kilogram by dividing 1000 and then multiply with 9.81. Calculation gave me the answer 0.48. The D part of this question, in next part of the question, the sphere is falling in air with terminal velocity 25, terminal velocity of 25 in SI base unit, mean meters per second. The density of the air 1.2, its SI unit, mean kilogram meter per cube per meter cube, and diameter of the sphere is 0.06 in SI unit, mean meter square. Diameter is in meter definitely. Okay, so I have to find out, use your answer in C. Answer in C. Where is the answer in C? Okay, this is the answer in C, 0.48. I will use the value of the drag, calculate the coefficient of the sphere, coefficient C for the sphere. So I already made this equation for C. C is the subject, and my final equation, 2 into FD, rho, area, and V square. So 2 as it is a constant. FD, we just find out the value 0.08. The value of the FD, this is 0.8, 0.48. Density is given in the question 1.2, and then uh, area. Okay, we need an area, but diameter is given. So you know well that area is equal to pi r square. And you know, if this is the circle, then this is diameter. So half of the diameter is r. So d will be equal to 2r, and r can be written as d by 2. So I will write the area in term of diameter, pi as it is, and r is equal to d by 2 and then square, so pi d square by 4. This is the value of area. So I'm going to write this same value, pi as it is, diameter is 0.06, and it is square also, there is a square also, and then divided by 4, and v is given to me, that is 25 square. 25 square. Okay, so final answers gives calculator give me the answer 0.46. As it is mentioned, the previous part C has no unit, so no need to write any unit. This is the final answer of this question.